Okay, so if you go to the projects, there are some new projects, and I'm very happy with these. Like I said, I think I really want everything to move to this Flare VM. But one problem with the Flare VM is that if you don't have a fairly powerful home computer, you can't run it. And now that is no longer true. Today, I finally found out how to do it in the cloud. You go to Azure. Now, when I first used Azure when it was new, it was really hard to use, and Microsoft didn't give you much free, and I got really irritated by it. But Microsoft has changed that. There's now this thing called Azure for Students. So if you go to this link, you'll see this portal for Azure for Students, the Education Hub, and all you have to have is an EDU email address. At least a City College one will work. So if you're a real City College student, you can get free Azure services and you can run Windows 10 in the cloud. So you sign up for an account there, they send you an email. You do not need a credit card number. You do need a phone to get a text message, but once they verify that your EDU email address works, they will give you $100 of credit to spend on the cloud. So then you can go here and click this 3-bar icon, and you can then create virtual machines. Now, Microsoft Azure is incredibly big and complicated. There are tons and tons of advanced, complicated things like load balancing and artificial intelligence and all sorts of things, but you can just make a simple Windows machine too. You create a virtual machine, and you can make a Windows 10 virtual machine in the cloud. And so you just fill out a little form and deploy this thing, and then you get a Windows machine. And up here, when you created it, you chose a name and password. And you just connect to it with RDP with the name and password you chose. So let me connect to mine. You just use any RDP client, and I use the Microsoft RDP client on the Mac, Microsoft Remote Desktop. And I just saved the IP address of the machine and my username and password. And now I have a cloud machine, and it's very powerful. And so I set up this cloud machine, and then I turned it into a Flare VM. And here is let me make this smaller so I can put other things on that screen. There we are. All right, so there's my cloud Windows machine. And here's my Windows Azure panel. You can see the metrics of your machine down here. So here you can see if I go to say 12 hours, I created the machine about 10 a.m. It took about 4 hours to make it into a Flare VM. So I just ran that script. It ran for 4 hours. It restarted a whole bunch of times. And then I had a Flare VM, and I could start working on projects, which is what I've been doing. And I don't know how much money I've spent of my $100, but I did make it so it'll automatically shut off every 24 hours to try to preserve it. I found a budget tab, but all it tells me is I still have $100. So yeah, I still have $100, which is, I guess they don't bill you continuously. I guess it'll wait until the end of the day or something before billing me. So I really don't know how much I've used up. Yep, still have $100. That can't be true, but anyway, hopefully if you turn it off and you're not using it, the $100 will last for a while. That part I don't know yet. But anyway, you can totally make a working Flare VM in the cloud now. So even if you have a lousy old computer at home that can't do anything but run a browser, that's all you need. Anyway, so that's one exciting thing. So you should all be able to get Flare VM. If you use RDP, are you vulnerable to attacks on your local computer? No, you're not. You're connecting to RDP on the server. The only thing that's vulnerable is that server. And by the way, Microsoft will warn you that your RDP is open to the internet, and that's really not recommended. So your cloud server is relatively vulnerable, but your host machine, this is like if you had a weak Gmail password, that would not affect your local machine. That would just mean somebody might get in your cloud service. So of course, don't put anything personal on that cloud machine. Yeah, that's a very good question. So as far as I know, this is quite safe. And that's your point. You want to, if you're going to do something like malware analysis, you want to be doing it on some machine that is not your machine you love with your personal data on it. So that's the whole point of it. Get you a cloud machine that's far away, that if somebody trashes it, you can just throw it away and you don't care. Anyway, so now once you've got one, then you can play with WinDbg and the DLL Proxy. There's 2 new projects. I've been trying to get up to this DLL project, actually I guess 3 new projects down here. You're going to need real Visual Studio. The Flare VM comes with Command Line Visual Studio 2015. and that is not good enough to perform DLL proxying. So first you have to install Real Visual Studio 2019, which is free, but it's big and takes a while to install. So you put on desktop development with C++, and now you can make software the way Microsoft professionals do with this Visual Studio thing. And Visual Studio is, I discovered, I spent the last 2 weeks struggling with it. Visual Studio is as messed up as maybe Linux software is. If you do Linux, you end up in dependency hell, where the program you're trying to compile needs something that doesn't exist in the right version, and you have to find it and try to port it over. And that, my Visual Studio is the same. If you go to, I found at least 15 blogs written by people telling me how to do DLL proxying, and absolutely none of it worked, because it would only work if you had exactly the version of Visual Studio they used. All the later versions keep changing everything, so the old code will no longer compile. And there are a bunch of settings inside Visual Studio that you have to adjust to make things compile correctly, and it took me a while to learn them. But I finally got this project working. So here's DLL proxy. I think I'll just talk about this one. All right, so in the Flare VM, we did this last week or 2 weeks, last time we met. We made a malicious program, made a malicious DLL, and we just put it in the path for a program that loaded a DLL that wasn't there. If it loads a DLL and it does not use it, which is a mistake on the part of the developer, then I can put in one of those malicious DLLs created by Metasploit, and it will work, because it will load the DLL, but it won't actually try to find an imported function, so it won't get upset. And that's fine. So now I'm going to exploit this program, bginfo64, which is a sys internals utility that just prints information about your system. It doesn't do anything important, but it happens to be vulnerable to this attack, like almost all software is. So if you run process monitor, which you've used before, and you filter to look for bginfo processes and paths ending with version.dll, then you will find when it runs. If you copy that program to your desktop, I made a desktop working folder called DLL proxy, it's going to look in that folder for this version.dll. And when it doesn't find it, it's going to go look and see Windows System 32 and find the real one and use that one. So this is the normal process of hunting for a DLL. And of course, this is the vulnerability, that it first looks in the working folder and it doesn't look here later. So you can try DLL replacement. You already have Metasploit. You installed it from a previous project. So if you run this Metasploit command, this will create a malicious DLL named version.dll. So you run this thing and then restart process monitor and restart the vulnerable process, and then look, and it is not listening on port 4445, which it would be if that DLL actually launched correctly. So the program was not fooled by this lousy DLL. And so you can find out why if you look in process monitor. It pops up an error message. It was unable to start because it loaded this DLL, but it figured out that that DLL wasn't good enough. Now the problem here is it's not just loading that DLL stupidly, it's loading that DLL because it wants to use it. It's looking for functions, and when it doesn't find those functions, it crashes saying, my library load didn't work, this is no good, I give up. And it does not run DLL main and run the malware. So we cannot fool this process with such a miserable, lousy imitation of a good DLL. We need to make a better forged DLL, and that's what DLL proxies are. A DLL proxy is something that will look just like the real DLL. So first you need to get a list of all the exports, and the easiest thing is use this utility from Nursoft. And if you download the DLL export viewer, I'm using the 64-bit version for this, then you can just load the function from any DLL. So here's the DLL that background info thing is going to use, called version.dll. You load the original real DLL, and it then creates this nice report showing you all the functions exported by that DLL. So it's got all this stuff, get file version and install file and whatever else it does. So now I have a nice table of the exports of that DLL. So now you run it through this Python code that I got from somebody's blog, and this Python code will just parse it, and it will create C++ code that fixes it. This is the code you want. This is the active ingredient of a DLL proxy. These are pragma commands, and what they will do is they will export something called get file version info A, and when they get a call trying to use that, it will go to some other DLL called version orig and pass it over there. So this DIL will just pass all the real calls onto the real DIL, and I can add more malicious code to it. So this is the active ingredient of the DIL proxy. And now you have to create the DIL that you're building. So you start with this code, which goes around, and this code is just a place to put in that DIL proxy code. And down here is part of the code that actually loads it. And here's the exploit that does the malicious thing. And here's the one I talked about before, DIL main, which loads automatically as soon as you load a library. So the process is going to be, when you put this in that folder and start bginfo, it's going to load this program. It's going to find all the imports it needs up here, so it's not going to crash. Then it will run DIL main to prepare it, and DIL main will run this exploit function. And the exploit function, in this case, just runs a batch file called payload.bat. So I don't have to modify this C code to do anything I want. I just need to write a normal Microsoft batch file to do whatever bad thing I want. And it will run when I run this DIL. So this is a very handy way to do it. And that's the game. So you build your program here. Now you have dilmain.cpp. This is the main C++ code you need to make the DIL. Now you need to use, you also need to make a payload.bat. And here I just made a payload that's going to put a file on the desktop called pwn.txt. Just a simple thing, just so I can tell it's working. So now you need Visual Studio 2019. You create a project. You have to make it a C++ Windows library, a DIL project, which is how you tell it that you're going to use, you create a library. You give it the same name as the real DIL version. And now you paste in the source code. And the only thing that took me like 2 weeks to learn is how to set all the parameters. This has to be release 64-bit. And then you have to right-click the name of your project and go to properties. And there are some things you must set in here. All configurations, all platforms, multi-threaded. And this one, which is very, very annoying, but now I finally figured out how to do it, not using precompiled headers. Precompiled headers are something that Visual Studio uses to make it faster, but you need to turn it off. And it's relatively hard to turn off. It took me a while to learn that I had to make this setting up here, or I keep turning it off and it doesn't really apply to the whole thing. Anyway, once you've done that stuff, you can just right-click this and build, and it will succeed. And now you have a DIL proxy with the name equal to the original DIL's name. Now you just put that in the same folder, and you put the original DIL in that folder. You copy the one from Windows System 32 into your working folder with the name version orig, because this proxy is going to call those functions. And now, when you run bginfo64, it's going to put this file on the desktop, and you'll be able to see what it does in Process Monitor. It will load the DIL proxy and run successfully and run the malicious activity. So it's really pretty nice. And this is a really popular activity. There are dozens of penetration testers all over the place using DIL proxying, and almost every one of them has written their own code to do it, because nobody else's code ever seems to work long enough for anybody to get much good out of it. So anyway, I'm happy with this. It took me a long time to get the pieces lined up to make it work. So that's DIL proxying, which is a good thing. And another thing, which you might check out, is this WinDbg preview. One of the students in this class is a Microsoft engineer, and I talked about how I'm using OllyDbg and the Windows debugger is really a drag. And he said, well, the Windows debugger has gotten better. You should try the new one. So I tried the new one, and I'm getting to find some virtues in it. It is not a replacement for OllyDbg. A bunch of things that are easy in OllyDbg are really difficult with WinDbg, but it has its own virtues. And so I'm starting to go through the official tutorial on it, and I got the first bit of it going here. So I'm just going to demonstrate this one live. So you have to add it. You must have Windows 10. As far as I know, you can't get it on any other Windows version. You have to go to the Microsoft Store, which is this thing here. And when you do, you can search for WinDbg. And there's a thing called WinDbg Preview that you can install here. And I've already done that, of course. And WinDbg Preview attempts to make it a little easier to use the ancient WinDbg utility. And it is a little easier, and it has a few exciting new features. A WinDbg. Oh, I don't have it. Oh, okay, I'll need to get it. This is my cloud machine. That's right, I've been running on my local machine. Well, let me just try putting it on my cloud machine. That should be fine. WinDbg. I say WinDbg. All right, WinDbg Preview. Install. The product is installed. Okay, good. Launch. Okay, so here it is. Now, I want to run it as administrator, and it looks like it is running as administrator, which is interesting. All right. So if it's running as administrator, I should be good to go. So notice I have a few graphical buttons here, and I have a place to put commands in the middle, and I have even the stack down here. So there's hope for this to be a little bit, it's a little bit like OllyDbg. So I can launch an executable, and I'm going to launch Notepad just to have a simple program to examine. Here's Notepad. Okay, so now what it has done, just like OllyDbg would have, it has loaded Notepad and it has stopped before it's really running. So if you scroll back up here, you can see what it did. It loaded Notepad, and here, this is one very nice thing. It finally automatically loads the symbol locations. This used to be the first thing you always had to do was to enter this information. Now it does it automatically. So it is connecting over the internet to Microsoft to get the symbols for my operating system. So it can give me alphabetic readable names for things, which is very nice. That process used to be manual and kind of annoying. So it loads Notepad, and here it is loading all the libraries. Here's the native API, ntdil, kernel32.dil, there's the other one, and all these others. These are all the dils getting loaded while it goes. You can see them go. Notice these numbers next to these libraries. This is the beginning and ending address of where that library is in memory. And by the way, you can tell if you run Process Explorer, which is installed by default on this malware analysis machine, then I can go to my Notepad. Well, which I thought I could go to Notepad. Let me check my instructions. Yeah, you should be able to find the process here. And I'm already seen to be in trouble. System, WinLogon, Explorer, conhost, WinLogon. I'm not seeing Notepad. Now that's annoying. Maybe I need to have it running for it to show up here. Oops, didn't mean it. All right, I'm going to try again. I fouled things up. WinDbg. I may have to work on this project a little more. I'm not finding the new WinDbg. When I do that, something is a little screwy here. WinDbg Preview. Here's WinDbg Preview. Okay, good. Right click, run as administrator. Okay. There we go. Now I open Notepad. All right, and I guess it's not really launched, so I think I'm just going to run it at this time. All right. If I run it, I'll be able to find it in Process Explorer. All right, because you can see there it is, Notepad launched in the back there. So now I should be able to find it in Process Explorer. And there's Explorer. There we are, there's Notepad. Okay, so if I click there and I go to View Lower Pane Dil, Lower Pane View, Show Lower Pane, and then View Lower Pane View Dils, I can see the libraries down here. And by the way, I can make that font a little bigger. Let's do that. All right. So if I go for the native API, for example, which is ntdil, it's loaded here. And if I go to properties, I can see where it is loaded. And it is loaded at this address, 7FF8C9FD. And that'll be the same thing I find here. If I find where it loaded ntdil, which is here. Those addresses will match. 7FF8, 7FF8, C9FD, C9FD. And then the other one is how big it is, 1ED1000. And this is the endpoint, which is another way to express it. So you're seeing the information as it loads them and where it loads them. And as you'll see, we can manipulate them and put breakpoints on them, which is very nice. So anyway, now I have run it. And what I want to do is view symbols. To examine symbols, it's running. I'm going to have to break it to get control of it again. And I'm just going to reload it. So I'm going to launch the executable again. And now it's going to automatically break right at the start, debugger break plus 30. This is what debuggers always do. It loads it in memory and stops so I can examine it. And so now I'm going to examine it here. I can examine notepad, bang, star. And that will give me all the process, all the symbols that start with notepad. So I have a lot of things here, in memory and file open error and so on. These are all the various symbols that refer to functions or variables or other things that are available in notepad. So that's too many things. Let's take a look at the ones that have the word main in them. So I created X notepad bang star main star. And now there's only a few of them. And you see, this is the one, this is the place where notepad starts running, win main. And this debugger is doing the same thing that we saw in IDA Pro. It has broken right now inside NTDill. So it has stopped at some internal Windows process, which is on the way towards launching my code, but it's not in the notepad code yet. So I would like it to really move to where the notepad code started. So I can put a breakpoint at that location. The name of this thing is notepad bang win main. So I can just put a breakpoint there with the BU command. So BU will put a breakpoint there at notepad bang win main. So I press enter and that succeeded. It doesn't tell me anything. Now I can just go right here. That will run and then stop when it hit the breakpoint. And now I'm in that location, and down here in the thread, it shows me I've moved from something called WinMain CRT startup is on the stack. And actually that's showing threads, and on mine it showed stacks before, which is a little screwy. That's interesting. I wonder if there's a way to adjust, view stack. Okay, good. Now I can see the stack. All right. And so what I'm seeing here are the stack frames. So I'm in WinMain, and WinMain was called by main CRT startup, and that was called by a kernel 32 thing, and that was called by an NTDill thing. This is the stack dump, and those are the. So I'm running all these things at once. This function ran, and it called this function, and that called this function, and that called this function. So they're all currently running, and they're all stopped, waiting for me to continue. But when this function finishes, it'll return back up the stack. So anyway, that's one thing. And I've made it to the breakpoint. Now I can view the loaded modules with LM. And this will show me all the modules that are currently being used by this process. The debugger is attached to one process, and it's showing me information about that process. It shows me the start and end memory locations of all these processes, and some of them have these PDB symbols, which we're going to play with in the next project. Those are the debugging symbols. You can compile code, and you can add debugging signals when you compile it, and that's what you should do with software you are developing, so you can then refer to your variables by name and such. But once you distribute code to sell it, or if you're making malware, you typically remove symbols. But some of these have symbols, like kernel 32 does and NTDill does. Others don't. Anyway, that is something there. Now here we have a summary of the stack, but I can get a more detailed stack trace with K. This gives me the same information you saw here, which function I'm in, but it also gives me the addresses. And this is the starting point of this stack frame, I think. And here's the return address, which is the last thing put on the stack. And so this tempts me to set up a buffer overflow and actually get a buffer overflow in here. And I might do that for one of the upcoming projects. I can already tell, I feel like writing 3 or 4 more projects about this tool because it's pretty good. Anyway, so now we can find API calls that create files. We can look in the NTDIL, the native API. So if I look here, I'm going to see all the symbols in NTDIL, and there would be too many of them. So I'm going to use star create file star, and I'm going to get the native API calls that create a file, and there's only a few of them. Temp, NT create file, ZW create file, and so on. So you can set a breakpoint at ZW create file with BU, and then continue. See if I can get this back to home. Oops, whoops, whoops, back home. All right, now I have a go button. So I can go, and it's going to move and then hit the breakpoint, because somewhere in the launching of Notepad, one of the first things it does is pop up a box and say, do you want to create a file? So it calls this function, and it has stopped inside this NTDIL function. And notice the stack is now much, much deeper. I'm now 30 hexadecimal, which is 48 layers deep in the stack. This function is called that function, and that function, and that function, and on and on. I'm all the way down here. So it's quite a chore. And if I do a stack trace, it's going to be pretty big. With K, there we are, all 30 hexadecimal layers down in the stack, starting here. All right. Notice, by the way, this stuff right here, there are numbers. I'm actually looking at the stack of a thread. Remember, each thread has its own stack. Each thread runs independently. This is the stack frame of one thread. The first number is the processor. I'm in processor number 1, and the second number is the thread number, and this is thread number 1. And that is not consistent. If you move to a different machine, you'll see different numbers. But anyway, right now I'm in processor 1, thread 1. All right, I can view all the threads in my process with tilde, shift back tick. And this has 3 processes. This, by the way, is weird and inconsistent. Sometimes I see 1, sometimes 2, sometimes 3. When I've seen this before, if I click down here, I would actually see 3 notepad windows. So I don't really understand what these 3 processes are. Sometimes it splits into 3 notepad windows. So I think that's probably a bug in this product, which is still in a preview version and not yet finished. But anyway, now I can see my breakpoints with BL. That'll show me my breakpoints. I have 2 breakpoints, one in Notepad WinMain and one in NTDIL. And you can clear them right here. This is kind of fun that you can use a mouse to do things. Of course, all it's doing is executing the command BC0. But still, you can use the mouse to clear them. And now if I look at the breakpoints again, BL, there are no breakpoints. So now if I run the program, it's going to actually run. It's still running. And I can do things like type stuff in here and try saving it because it's running. I cannot execute any more commands while it's running. If I wanted to execute a command, like to put a breakpoint back, I'd have to break it here. That'll stop it and give me control of it again, but it stops it at some random place. So if I want to get back to a controlled place, I'd have to restore the breakpoint and put it back in. Anyway, that's as far as I got so far. And the next step, of course, is to write our own program, compile it with Visual Studio, add the debugging code, and then debug a real program in this thing. And the one thing that would be good is to learn how to use this time travel thing. It's got some kind of time travel feature, which I guess means you can go forward and backward through the code. And I'd like to see how that works. So it does not have all the functionality of OllyDbg, but it has new and interesting functionality that's worth learning about. Anyway, I think that's all I wanted to show you today. Let me take a look. Yeah, DLL Proxying, Visual Studio. DLL hijacking was last week. And you got this Azure cloud server, so everybody should be able to do this, even if you do not have a strong enough machine at home to run a local copy of Windows 10 in a virtual machine. So this is real important to me because I want to teach a class in this stuff in the future at City College, and a lot of my students don't have good machines. And it looks like we're not going to have any face-to-face classes for the next year. The doctors I hear about say that we really can't expect this pandemic to be over before November of next year. But anyway, we will see what happens. So that's what I wanted to show you. Why'd you cut off the recording during this demo? I did not. It should still be running. It's recording. I'm just going to end it right now. I did not end it.